Hi Roberta, hi Vivi. We'll be starting soon, so just to check, can you all hear me? Hi Amos and Veron. Hi Amos and Veron. Okay, I think the mic is working. Hi Cindy, hi May. Hi Adeline. Okay, I think my setup is correct, so we're ready to go. Okay, good evening. This is Kevin from Maths Heuristics. I believe the SA2 is over, or will be over soon, for most of you who have children in P4. So the thing here is, the reason why I'm organizing this talk today is that I've received a lot of inquiries from P5 parents over the years in my line of work. Pardon me, I have a bit of a sore throat that I haven't recovered from. So year after year, what parents observe is that during the CA1 and SA1 of the P5, they tend to suffer a grade drop or so. So there are a lot of parents that are concerned about this grade drop and what they can do about it. So today I will be talking about how to master heuristics effectively and efficiently in P5. Okay? So before I do that, is it alright if I talk a bit about our company and what we do? Hi Santalam and Ben. Hi Joanna, Jamaica. Okay. Right, let's get on to it. So about Maths Heuristics. We started out as an enrichment center back in 2008. It was founded by Mr. Sari Tan, an ex-MOE teacher and the creator of the unit transfer method. So together with him, we developed this total integrated learning platform for complete mastery of heuristics. That is our brand promise. So it consists of classes, guidebooks, web videos, mobile apps, and a virtual classroom. So these guidebooks are not assessment books where they have a lot of questions for you to do. It details the thought process and the problem-solving process, step by step, so that when the child understands it, he is able to replicate it to more unfamiliar situations. I'll cover more of that later on. So more about myself, I'm the curriculum specialist here. I started working here in 2011 as an intern, graduated from Nanyang Technological University with a degree in Bachelor's in Mathematics and Economics. So, I guess most of you know me already. Hi Nelson. Okay. So let's talk about why your child could possibly experience a drop in his or her maths in P5, even though he or she scored 90 plus for her P4 exam, P4 SA2 exam. So you will be thinking P5 is no big deal, but I beg to differ. Okay, I will explain why, in my opinion, P5 is more important than P6. Okay, it is my duty to inform all of you why it is so. So let me get started with this. Hi Cecilia. Okay, the reason number one. P5 is the crucial transition period between P4 and P6. It is a sneak peek of what he can expect in the PSLE. Okay, so in P5, they will be trained in topics that will be further covered in P6. It is, and all these new topics and concepts, like in P4, what they covered is whole numbers, fractions, decimals, a bit of geometry, a bit on area and perimeter, Nothing too difficult in my opinion. So at P5, they will be covering new topics such as percentage, ratio, geometry, further elaborating on the quadrilaterals, volume, harder problems in area and perimeter, and so on. So based on this, they need to solve more challenging problems based on what was previously taught already. And all these will require higher order thinking skills. So, and now reason number 3 is the range of mathematical heuristics at up to P4, the exposure is quite limited. So they will cover things like guess and check, and usually this only involves 2 items at most. Patterns, working backwards, and so on. In P4, the main focus is on models. You would agree with me on that. I tend to present my solutions with models for P3 and P4 because I understand that that's what they are exposed to. So at P5, the range of heuristics is much broader, and it will cover deeper into these concepts. Okay? So let me talk about the baffling reality of PSLE. So all these are newspaper articles that we've collected over the years. Now let me talk a bit about these 2 articles first. This article, in this particular article, it is said that a popular school, there's an uproar in a popular school because the teacher decided to focus on section A and B and neglect section C. So that was 1 month before the PSLE results came out. After the PSLE results came out in November in that year, what happened is that a lot of students got D and E. So there's a lot of ways you can go about this, but you cannot neglect the problem solving component. At that time, it was weighted about 50%. Okay? Then the next one is this particular article here. Debate over maths paper continues. The summary of this article is that the parents want to see the entire paper in the Straits Times because they published 3 questions that year. So the parents wanted to see how difficult it was for themselves. And next, in this article, there was a question on whether algebra can be used to solve PSLE problems or not. So this part I will elaborate more later. And by now, you should know that there's this tricky ribbon question that just came out this year. And this coin, estimate the weight of the coin question that came out in 2015. All these are infamous. And the thing about PSLE is the difficulty level would not vary too much. It will either stay the same, plus or minus a little variance, or it will be more difficult. Okay, so let me elaborate on this particular article. In response to the question on whether algebra can be used to solve PSLE maths problem, this was what came out in the forum. Different approaches taught for mathematical techniques. So this statement was made by the then director of curriculum Planning and Development Department, Miss Ho Ping. So I quote here, they are encouraged to try different approaches and have the flexibility to choose the method that works best for them. In a separate paragraph, in the marking of PSLE, all mathematical correct solutions are acceptable, including algebra. And why is this important? Now let me talk about what is required of the child in P6 first. Let me work backwards and develop the chain of thought for this. The curriculum framework is as follows. The primary aim of mathematics curriculum is to enable pupils to develop their ability in mathematical problem solving. And this has been the central focus for several years, and it hasn't changed. And to deal with problems in unfamiliar contexts. And open-ended investigations that make use of the relevant mathematical thinking processes. So what is unfamiliar context? Unfamiliar context means that you never heard of the problem before, you never seen it before. For some reason, they are very creative and can somehow get and set a question that is unfamiliar. And every year we are bound to have unfamiliar problems because of this. Okay? Next, on the use of calculators in 2009 PSLE. So back in 2006, this was introduced. The introduction of calculators in P5 and P6 reflects a shift to give more focus on higher order problem solving skills and heuristics. So as you all know, we've been living in Singapore for several years. For myself, it's almost 30. So that's how long I've been around in this world. Therefore, the focus will not be on computation. Because when you are given something in Singapore, something is expected of you in return. It will not be easier, it can only get harder, because now the focus is not on computation, but rather on higher order problem solving skills and heuristics. Okay? So what are heuristics? They are strategies designed to solve challenging and non-routine problems, and the Ministry of Education has identified 11 heuristics applicable to the primary level, 13 to the secondary level. So by now, every one of us should know what are diagrams or models. Using before and after scenarios, which we cover a lot. Acting it out is more for lower primary, for them to walk through the whole concrete process and appreciate the flow of the problem, so that when the questions get more complex, they can relate to that and draw on that experience to understand it better. Systematic listing, looking for patterns, working backwards, guessing and checking, simplifying the problem, making supposition, solving part of the problem, and paraphrasing the problem. Okay, so you can see that the last two heuristics are for the secondary level. It's on writing on a related problem and using equation. So this is quite important, because the use of equation is not recommended at the primary level. And you must be wondering, in that case, why is algebra taught in P6? Okay, I know what you're thinking. But if you look carefully, in P6 what they are taught is algebraic expressions. Alright? So that is one confusion alert. And now that we've identified all this, let me just say something. We have a world-class government with a world-class education system. There is no way we can beat the system. The best bet that we have is to follow it and hope that something good comes out of it. Now, let me talk a bit about what are the differences between routine problems and non-routine problems. Routine problems are problems that assess knowledge, like what is the value of 4 in 854,013? Well, it's just 4,000. Nothing much to that. Basic computational skills, find the value of 3/4 multiplied by 6. So this is just going to be 18 out of 4. That simplifies down to 4.5. Nothing too difficult, it's quite mechanical. Okay. Then routine procedures as well. Find the area of a triangle. So now that you see this triangle, you know that it has a height of 12 and a base of 20. It can just be found by taking half times base times height. That gives you 120. Okay. And a familiar word problem looks a bit wordy, but it's actually quite simple. She pays a membership fee. Okay, Lynn joins a club. She pays a membership fee of $45, and she also pays $5.50 each time she books a tennis court. And she books the court 30 times. How much does she need to pay the club altogether? So we link up these two statements, and we see that 30 times $5.50 means that she will need to pay $165 for booking only, and she needs to pay $45 for the membership fee. That will give you a total of 210. Up to here, up to these routine word problems, drill and practice with understanding should be able to handle it quite easily. Of course, you need to be careful and all that in dealing with all these to avoid careless mistakes, but that I don't wish to talk about those tips at this point. So what about non-routine problems? Non-routine problems emphasize on looking for patterns, such as this problem here. JPS stands for Jurong Primary. School. Okay, what is the number of ways to travel from point A to point B using a 4x4 grid below? Now the restriction here is that you can only travel in the south direction or the west direction. Then you will be thinking, okay, I'll just list out everything. 1 way, 2 ways, and so on. Well, eventually, if you do this, eventually you will get the answer, which is 70. Which is why I say eventually. At this point, it is not wise to start off by going into systematic listing first. You have to be able to look for a pattern to solve this problem. I'll not elaborate on it because I don't have much time. But if you want, you can try this problem. The final answer is 70. Okay? You need to look for a way a pattern to generalize and solve this problem. Without that, it's going to take a very long time to solve. Next, emphasis on looking for patterns and listing. A millipede is crawling up a slippery wall in a straight line without resting. For every 3 cm it climbs up, bump, 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 it slips down 1 cm down the wall, and it takes it 3 seconds to climb up 1 cm, 1 second to slip down. How far would the millipede have climbed after 1 minute? And what is the shortest time that the millipede will take to climb 56 cm? So this is an item from PSLE. Unfortunately, I don't remember the year. It's definitely not as easy as it seems. For part A, it's quite straightforward. For part B, did anyone work this out? What was the answer that you have? Okay, but I won't go too deep into this problem. The idea here is you need to group 2 pieces of information up together. For every 3 cm that it climbs up, it slips 1 cm down the wall. So it has to be grouped up as such. So every time it climbs up to effectively in one set, it climbs up 2 cm. What is the time taken? But part B is not that straightforward. Okay, if you thought that the answer is 280 seconds, no, it's not. It's 276 seconds. I'll leave you to find out why. Okay. Now, they also emphasize on complexity. Non-routine problems like to do this. Now, you see that Paul and Ray worked together to paint a house. During the job, Paul rested for 4 days and Ray took 2 days off. However, they were not absent on the same days. If they had done the job alone, Paul would have taken 18 days and Ray would have taken 12 days. How long did the 2 painters take to complete painting the house? So this is from Henry Park. I won't solve it here. The final answer is 10 days. Okay, that is how they emphasize on complexity. First, the topic itself is not that easy, it's red. Second, there's a lot of interpretation to be done. And third, there's a lot of information that needs to be synthesized together for you to evaluate it properly. And another emphasis on complexity, this question has been asked in Maths Model Method very frequently. Jim bought some chocolates and gave half of it to Ken. Ken bought some sweets and gave half of it to Jim. Jim ate 12 sweets, Ken ate 18 chocolates. Ratio of Jim's sweets to chocolate became 1:7. Ratio of Ken's sweets to chocolate became 1:4. How many sweets did Ken buy? Then here in itself, you see that you have another kind of structure that you need to deal with. So that is the complex part. Now let me talk about the new PSLE format that will be coming out in 2018. So the main things that has changed is that your total number of questions is now 17. The duration is now 90 minutes. The weightage has also changed to 55%. So being a mathematician myself, I like to calculate things. The average time you need per question is about 5.3 minutes. Around 5 minutes, just for simplicity. Okay. So every problem needs to be solved within 5 minutes on average. Some questions will be shorter, some questions will take a bit longer, but on average they need to be solved within 5 minutes. Then the thing is, for some of us, we take days and we cannot even solve a problem. So we ask friends, and they also cannot solve for us. So what do? We go to the forums and seek help. Correct? So that is what is required of the students in P6. They need to be able to handle routine problems and non-routine problems. But the main focus of my webinar here, is on the non-routine problems. Now, with a better understanding for what is required at P6, let me just show you what they will experience at P5. But before I show you what they do at P5, let me relate it back to the models that they are familiar with first at P4. So the first one is on before, change, and after. 6 out of 7 of the buses were owned by Company C and the rest by Company S. Company S bought another 42 buses and now owns 2/5 of all the buses. How many buses does Company S have now? Now, first thing you need to do is identify what is given and interpret the statements. So 6 units is owned by Company C out of a total of 7. This is a tricky part. The rest is owned by Company S. They have to infer that this is 7 minus 6, and that leaves you with 1. This was before anything happened. The change is the action that Company S took. Company S bought 42 buses, now owns 2 out of a total of 5 of all the buses. Okay. How many buses does Company S have now? This is hereafter. So let me start this out with model drawing. Between Company C and Company S, we see that Company C has got 6 units. Company S has 1 unit. Okay, when you read this statement, if Company S owns 2 out of a total of 5 of all the buses, it also means that Company C owns 3/5 of all the buses. They've been trained to do this, so don't worry too much. And once we see this, we want to split Company C into 3 groups. The way to do it is, we draw this down. We see that Company C can be grouped up nicely, like so, into 3 groups. In that case, there should be 2 groups for Company S, because Company S owns 2/5 of all the buses. Okay, so we draw it out like this, and then we see that Company S will have this much now. We observe that the change of 42 buses came from these 3 blocks, so we can say that 42 divided by 3 gives you 14. How many buses does Company S have now? That will be 4 blocks or 4 units. So 4 times 14 will give you 56. Answer is 56. Very nice, right, the model? But as we go on further, we will see that it is more difficult to use models, and I'll explain why in a while. So this is considered a hard problem at P4. If this were to come out at P5, this would be considered easy. This problem will be quite difficult at P5 because they are starting to learn the ratio somewhere around term 2. Now you can observe that the question structure didn't change much, only some of the fractions and the numbers. Okay, now 5/6 of the buses are owned by Company C and the rest by Company S. This was before anything happened, so we interpret the problem again. 5 out of a total of 6 is owned by company C. Company S must have 6 minus 5 to give you 1. Company S bought another 112 buses, this is the change, and now owns 2 out of a total of 5 of all the buses. This is your after. Okay, the key thing here is that to interpret this part, company C has 3 parts, while company S has 2 parts. Okay? So when you try to draw out the model again, at first there's nothing much to it. C would have 5, S would have 1. Now when you try to draw the after, you need to group C into 3 equal parts. So how would you do this? It will be a bit challenging from here, correct? The way to do this is you have to split everything nicely, like so. Every block needs to be cut into 3 smaller blocks so that every group or every part will be 5 of these smaller blocks. Okay, then for company S, it would have 2 of these big groups. So in this particular situation, it is easier to use the one-shot model. Then we can observe that this 112 should come from here. 1, 2, 3, 4, 5, 6, 7. 7 units is this 112 buses that increase. So there's no need for the after model. We know that this is our after result. Okay, so then 112 divided by 7 would give us 14. How many buses does company S have now? That will be 10 blocks. So that will be 10 times 14. That will give you 140. So the final answer here is 140. Okay, still quite manageable. The hard part came when the numbers became a bit unfriendly. Okay, and at P5 by right, this should be considered easy for them later on in the year. Now number 3, type 3 is a BCA problem. It is a higher order thinking skill problem. Tom had a box of red beads and yellow beads. When he added in 30 red beads, okay, let me read out the whole question first before I analyze the problem. When he added in 30 red beads, 20% of the beads were yellow beads. He added in another 100 yellow beads, and as a result, 60% of the beads in the box were yellow. How many red beads were there in the box at first? So you want to find red beads at first. Okay, let's look back at the problem. This was before anything happened. The first change came when he added in 30 red beads. Now as a general rule, what I tell my students is to change the 20% into a fraction first. How do you do that when you don't know what to do? Just press your calculator. Your calculator should be your best friend in P5 and P6. Okay, so that is 1 out of 5. After they've learned percentages, they can go by the definition. So change this to 1/5 of the beads were yellow. So this is your after. Added in another 100 yellow beads. This is the change. Now as a result, 60%, which is 60 out of 100 by definition, simplifies down to 3 out of 5. 3/5 of the bits in the box were yellow. How many red bits were there in the box at first? Okay, so let's map out the entire problem. If you want to do this by model, it can be done. It will be much harder to draw it out compared to the previous problem, but it's still possible. So instead of using models for this, what I will show you is the unit transfer method. But before I do that, let me show you the unit transfer method in the previous problem first. Okay, so why do I want to do this? For those of you who are new, who's seeing me for the first time, I want to show you how to relate models to units and parts. This is important because when the students learn ratio without linking it to the previous knowledge that they have already acquired, they tend to not appreciate the concept as much. So this is important. Now let me solve this problem again, now by the unit transfer method. So here's how it goes. Maybe I need to move my video first. Okay, 5/6 of the buses were owned by Company C and the rest by S. That was before anything happened. Company C, Company S, before, change, and after. Now, right now, what we are doing is we want to quantify the number of blocks that each of them had at every stage. So Company S buys another 112 buses, and now they own 2/5 of all the buses. So this is 2 out of a total of 5, which means that Company C has 3. Alright, what we teach them is to look at the change row. In a before and after, the change is the most important component, because without the change, there's no before or after to talk about. We observe that this 5 units is equal to these 3 parts. So we want to make them the same. And by equivalent ratios, this becomes 15, this becomes 3, this becomes 15, and this becomes 10. It is exactly like what we did for the model drawing earlier. We can observe that from 3 units up to 10 units, there was an increase of 112. So we say that the increase was 7 units. 7 units is 112. 10u minus 3u gives you 7 units. 1 unit will be 112 divided by 7 to give you 14. Company S now has 10 units. And that is how you relate and bridge from pictorial to abstract. Okay? When you have this, when you understand this, it becomes much easier to deal with higher order thinking skills types of problems. So to solve this problem, I will extend that logic further into this. So you have red and you have yellow. We identified that there's before, change, after, change, and after. Okay, let me move my big head down again. Okay. So at first, you are not sure about how many red bits or yellow bits they have. We skip that. We move on to this change. You added in 30 red bits. And now 1 out of a total of 5 of the bits were yellow. So yellow is 1 out of a total of 5 over here. Between these two, red must be 4. He added in another 100 yellow bits. So this now becomes plus 100, and 3/5 of the bits in the box are now yellow. So this is 3 out of a total of 5, which means the red must be 2. Now when we observe this problem, we cannot start from the front because it is not known. But since your end result is known, we can focus on it and work backwards. So this in itself is a before, change, and after scenario. We can observe that there is no change between these 4 units and these 2 parts. We say that these 2 are equal, make them the same, multiply this by 2, this becomes 4, this becomes 6. And then we observe that from 1 unit up to 6 units, there was a change of 5 units, which is this 100 over here. Then 1 unit must be 100 divided by 5 to give you 20. Finally, we are supposed to find the number of red bits at first. So this is our objective. We need to know how many red bits there were at this point. So that would be 4 units, which is 4 times 20 to give you 80. When you know that this is 80, you can work backwards and find out that this has to be something plus 30 gives you 80. Therefore, 80 minus 30 should give you 50. Okay, so the final answer here is 50. Alright, at P5, this is considered higher order. But at P6, this is considered at most intermediate difficulty. Basic to intermediate, actually. Okay, the idea here is that how was this problem solved? First, we interpret all the mathematical language and just put them in the table first. After that, we try to synthesize them together, connect the dots, connect all the points, connect all the information, and then after that, we went on to evaluate for what is required. So that's all there is to it. You will have to list down everything first and try to synthesize them later on. Okay. And for this next problem, I talked about this earlier, but I will not be solving it. Okay. The variations, there are too many variations that can come out in a problem. There is no way you can memorize every single one of them. You can memorize a few things, a few problem-solving processes and tools. And after that, depending on the situation, apply them to the best of your ability. The main focus you need is the problem-solving process skills and not to memorize every single comparison or whatever they call it. So how can we at Maths Heuristics help? Here we have a total integrated learning platform. Okay, this is Singapore's first total learning integrated platform. This one I dare to say because I don't see anyone else with it. Okay, it consists of classes, books, web videos, which reinforces the book's concepts. Whenever you get a guidebook from us, now you will get the access to our web videos. The mobile applications that are catered more towards kinesthetic and tactile learners, those that need to fidget or press something, and a virtual classroom consultation with myself. And for this, we have the modules, which I'll elaborate further, and holiday workshops, which is coming up soon, and an e-learning platform that trains parents in techniques and equips you with the training resources. As much as we want to see your children 24/7, we cannot do that. So this is the best alternative that we can think of. Okay. So for 2018, Term 1, classes are open for registration for Primary 3 to Primary 6. So in the unit transfer method, we will be covering the 5 major topics: whole numbers, fractions, ratio, percentage, and decimals. Now these would cover the before and after scenarios, paraphrasing the problem, solving part of the problem, and for certain aspects, we will also use models to help the child visualize the problem-solving process better. In the model approach to problem solving, we will be covering the stack model and split model, and of course the conventional model. Now for some students who are not so visually inclined, we will also introduce them branching. Okay. Then as for the heuristics approach, it will cover most of the 11 heuristics, such as guess and check, systematic listing, add patterns, working backwards, making suppositions, and this is more for P6. We would cover the topic of speed. This is in Module 3. Module 3 is usually around mid-May. Okay. Then on higher order thinking skills, once your child has been exposed to the 11 heuristics from the first 3 modules, you'll be wondering which is the best heuristics to use for this type of problem. Well, for my stand is the best approach is the one that the student is the most comfortable with. He can execute it consistently and get it correct. And he must be comfortable with it. If he uses a method that he's not so comfortable with, but is supposed to be faster, but ends up getting it wrong, then I would suggest not using it. Just use what he's comfortable with. That is my stand. So how does this HOTS come into play? It will revise all the 11 heuristics and it will train them to filter out which one works best for them. Okay. Now lastly, on our November bridging program happening on 21st and 22nd of November, this will be on Tuesday and Wednesday. It's for students who are going to P5 or P6 in 2018 for our 2018 programs. This will be for P3 to P6. Let me just type out the link here. Okay, yeah. Okay, so are there any questions? Oh, Jason, sorry. Can parents attend workshop in November? No. It's meant for students. Okay, Peter, that one I'll address that later. What time is the bridging program? Okay, 2 p.m. to 6 p.m. Oh, by the way, for this bridging program, what we would do is, we know that we will only be seeing them for about 8 hours at most, over 2 days. So, what we would be giving is the complimentary online program which we described earlier over here. So this will support them all the way up to PSLE for the unit transfer method. Okay, so there are more details that you can click on the link. If you want to find out more. Okay. Is the location. The location will be at our office at 195A Gold Hill Center. So that is at Thompson Road. You're welcome, Roberta. For more information, you can click on the pin post and have a look at what is appropriate. Fees. You're welcome, Vanessa. Welcome, Cecilia. Oh, hi, Pro 3. You're welcome, Wai Shin. Welcome, EM. You're welcome, Bear Bear. Jeju Bear, what should I call you actually? Okay, so I guess if there are no other questions, this is Kevin from Maths Heuristics signing off. Have a good night. So now that your exams are over, hopefully you can sleep better and so can your child. See you soon.